Hello guys, today we are going to see about the design patterns. In my previous video, I have explained about the design principles. Design principles and design patterns both are different concepts. Design principles in the sense they are the guidelines or the best practices that we need to follow when we are designing our website. That means due to the best practices, you can build a good solution. But in the sense of design patterns, these are the common solution for the recurring problems. When you are developing a website, you may face a lot of problems, but some of them may be recurrent. That means the same problem faced by all the people around the world, the most of the people around the world. So there are some predefined solutions for them. These solutions are called as the design patterns. There are a lot of design patterns already defined. They are um, Singleton, factory. There are a lot like that. Already there are 23 design principles written by in the book of Gang of Four. So now let's see what are design patterns. As I have already mentioned, design patterns are reusable solutions to the common problem. Common problem in the sense recurring problem in the software design, architecture, and programming. Design patterns are not specific to any particular programming. We can use with any programming language that we are developing for the web design because these are like kind of general solutions. So due to these general solutions, we can able to build a good software product. That means able to maintain a high quality and uh, able to use the reusable software because that means these are the common solutions for the recurring problems. So these solutions can be used in all the situations. So, in the sense of design patterns, there are mainly three design patterns. They are creational patterns, structural patterns, and behavioral patterns. Before diving into this topic, by the way, I am Tibana Govindaraja, and this is my own article which I written in my WordPress website. That is tipsbook.wordpress.com. Okay, tipsbook.wordpress.com. And if you have any doubt, you can contact me over my LinkedIn. My LinkedIn website is also Tibana Govinda Raya. So if you have any doubts, you can contact me over there. Okay, now let's move into the topic. And there are three main design patterns. These are a creational pattern, structural pattern, and behavioral pattern. Creational design patterns in the sense they are focused on the creation of the objects. That means they will tell how you have to create the object. So, example of creational design patterns are singleton, factory, abstract factory, builder, and prototype design patterns. We will see few among them. And in the case of structural design pattern, the word structure represents the meaning. It will define how the classes and objects should be, how the patterns should be. So focused on the composition of class and objects. Examples of structural design patterns are adapter, bridge, composite, decorator, facade, flyweight, and proxy. And the last one is the behavioral design patterns. Here also the word means the sense. Behavioral, how it behaves. So it, as the word represents, it focused on how the object communicates between each other. So how objects interact with each other to complete a task. Examples of behavioral design patterns are chain of responsibility pattern, command pattern, interpreter pattern, iterator pattern, mediator, memento, observer, state, strategy, template method, and visitor. So these are some examples. We will not focus on each and everything. We will focus on only the important design patterns below. Now let's move into the first design pattern, that is singleton pattern. As I have already mentioned, singleton design pattern is one of the creational design pattern. And this is a very easy pattern. Normally, every software developer should know about the singleton design pattern because this is the first design pattern you will study each and everywhere where you see. So, what that means? As the name represents singleton, sinker. So it should have only one instance. Instance in the sense it's an object. So it has only one object for that particular class. So if there is only one object, it will have only one global point of access. So singleton patterns ensures that the class have only one instance and provides a global point of access to that instance. So, singleton pattern is useful in situations where you need to ensure that there is only one instance of a class. That means there is only a single instance, single object is present. So, in this case, you will apply singleton pattern. In order to make the singleton pattern, you can able to use four different methods. These are slightly different from one another. First, let's see the first method. That is lazy instantiation. Lazy instantiation means in the class, here there will be a private constructor. So private constructor prevents instantiation from outside. So you cannot make the instantiation from outside of the object. You private means you can access it only within the class. So within the class, I am calling this public instance, public static singleton get instance. So in this instance, I am going to create an instance and return that. So in order to create the instance, I am making sure whether that instance is not already present. So if that instance is not present, it will create the new instance. And if that instance is already present, that means if it's not equal to null, then it will simply return only the instance. So here only one instance will be created because if the instance is already created, it will not be returned null. So it will not be equal. So this statement will not again executed. So executed only one time. This is the lazy instantiation. And in the case of eager instantiation, instead of creating that object in the public access point, you are creating the object here. The difference is here you use the word final. Here you haven't used the word final. Here, the final represents that you are not again creating the instance. Only one instance is created because final word represents that it cannot be changed in the future. It is fixed. It is permanent. So only one instance is created. And here you are just returning that instance, not creating like the lazy instantiation. But problem with the eager instantiation is if you are not using this method also, you are creating the instance. That means if you are not needed to, sometimes you are not, in the case you are not needed also, you are wastefully creating that. So the drawback to eager instantiation is that method is created even though the client application might not be using it because we are not sure whether we will call this get instance or not. But however, when the class is created, this instance will be created. So it's waste of resource. And the third one is is static block instantiation. This is also similar to the eager instantiation. That means our second method. So here also we will create before the get instance. That means before the public access point. That means that's also waste of resource before, because in the public access point only we are accessing it through the client code. So sometimes if we are not accessing it also, the instance will be created in the eager instantiation as well as the static block instantiation. But the difference is, in the static block instantiation, we are using static block for exception handling. That means here you are in a try, you are creating instance. And if there are any errors, that means for example, if you are trying to create the instance again, or if you are doing something again, then it will be error. So it will be throw the exception, one time exception. So that is the third method called static block initialization. So it provides the option for the exception handling. And the last method is thread safe instantiation. This is similar to the lazy instantiation. But one problem with the lazy instantiation, that means our first method is, what will happen if two threads are executed parallelly? Let's say one thread A is in the step here. That means creating the instance. And thread B is executing this step. So, when thread B executing this step also, it will return false because it's still not created. Thread A just now creating it. So, due to that, second instance also created. So, it will be problem when multiple threads are executing parallelly. That's why we are introducing new method called thread safe instantiation. That means, as the word implies, when the multiple threads are executing also, it will be safe to use. So what we are using is, we are using the keyword synchronized. This is the different from the lazy instantiation. Other code are same. The extra difference is we are using the word synchronized. So the keyword synchronized ensures that no two threads cannot be executed in this method at the same time. So thread A and thread B, or only one thread can be executed in this method. So no further instances will be created. So now we have seen about the singleton design pattern. So singleton design patterns, in the sense we have to use it when we need to create only one instance for that particular class, and we need to have only one global access point. So in order to use singleton design pattern, we have four methods or lazy instantiation. The problem with the lazy instantiation is with the multi-threading. So due to the multi-threading method, we are using the thread safe method with the keyword or synchronized. And eager instantiation is not a good method, since we will create the instance even the client code just not call that. And the static instantiation also, here we are providing the option for the exception handling. So we have seen about the first method, and now we are seeing about the second method, factory method pattern. This is also the creational design pattern. Here, why we are using this method is, it provides an interface for creating objects, but allows subclasses to determine which class to instantiate. That means we are creating objects, but subclass only determine for which class we need to instantiate. That means we need to created object at the runtime. So the factory pattern is useful in situation where you need to create multiple instances of objects that share the common interfaces, but where the specific class being instantiation may vary depending on the runtime condition. That means on the runtime you will decide for which class you will need to instantiate. That means you need to create the object. So here I have the interface shape. Using that interface, I have defined two classes, class rectangle, which implements that interface shape, and class circle, which implements that shape. And I again create the class called the shape factory. In the shape factory, I have in the shape factory, I have check the shape type. That means I have instantiate that class. So this is the common phase to create the object. But we are creating the object on the runtime. That means in the main method. So according to what we are passing here, we will create the object. But the method for creating object is created in is present in a common interface. So this means that this provides an interface for creating objects. So this is an interface for creating objects, but allow subclasses to determine which class to instantiate. So here in the runtime, we are deciding. That means if we give the word rectangle, we are instantiate that rectangle. So in the so the subclass determine which class to instantiate. So we are determining in the runtime. So we have seen about the second method called the factory method. Here the thing is we are provides an interface for creating object but allows subclasses to determine which class to instantiate. And we are going to see about the third method called abstract factory method. The main difference between the factory method and the abstract factory is that here in the factory method patterns creates an object through the inheritance. But in the abstract factory pattern, we create the object through the composition. Factory pattern, we have created the object using inheritance. In the abstract factory method, we have created the object through the composition. Abstract factory method also creational design pattern. We are going to see about the fourth design pattern, that is builder pattern. Builder pattern also creational design pattern. As the name suggests, builder. So it provides a separate, it's used to separate the construction, that means building, of a complex object from its representation. So that is used to separate the construction of a complex object from its representation. So what's the benefit of it? We can use the same construction process to create different representation. So let's see the real world example. Here we are need to create the email object. So email object can have the attributes like email from, to, subject, and body. Build a pattern can be used to create the email object with different attributes. Because for the form, to, subject, body, we will pass the different attributes. So we will provide the separate interface for building the email object. So what we are doing is, here in the email, we are holding the constructor. And thereafter, as the inner class of the email, we are again calling another class, public static class email builder. This is the builder class. We are creating as the inner class of the main outer class. Here we are calling each and every from to subject body. And finally, we are building email build. In the email build, we are returning the constructor of the main email method. So we can able to create that. So email builder, that inner class is used to build the email object. So how we are going to use it in the when we are passing the different examples. So since email builder is the inner class, we we have to provide that email builder. And for the form to subject body, we can able to pass the different functions, different parameters, and then able to provide the build. So here what we can able to do is we can able to pass if we want these three only. That means we can able to use the different constructions also from two subjects. No need to pass all the four things here. We can pass only just one thing, or we can pass only two things, we can pass only three things. So we can able to do the different methods of creation using this same format. The fourth one is the facade pattern. The already things we have seen are singleton design pattern, factory design pattern, and builder design patterns. All three are the creational design patterns. It says how we need to create the object. But here, we are seeing about the structural design patterns. So facade pattern is the first structural design patterns we are seeing now. Structural patterns gives the sense how we need to structure them, how we need to create structure class, objects, all these things. So it provides a simplified interface for the complex system of classes, interface, and subsystems. That means it provides a simplified interface. So what it's really doing, it hides the complexity of a system. So by hiding the complexity of a system, you're just providing a simple interface. That means client only knows how to use it. It will not know how you have really implemented. For the example, let's take driver paddles the brake of the car and the car stops. The driver only knows brake paddle. He not knows how the brake paddle stops the car. So, how the brake paddle stops the car is the complex function. Driver don't know about this complex function. He only knows the simple interface. When he presses the pedal, the car stops. It was the simple interface the car driver knows. As similar to that, facade design pattern provides a simplified interface for the complex system by hiding the complexity of a system. So, in the facade interface, we will have some other packages. We will have some other subsystems. But here only we call them in the facade class. So only client knows how to do it. It will not know how it's really implemented in the subsystems. So if you see the example, in the facade class, you have the subsystem 1, 2, 3. In these subsystem 1, 2, 3 are the separate classes. Subsystem 1, 2, 3. Here we are calling these subsystems or classes only. So it only knows how to perform these operations. It will outside of the class will not know how these subsystems are implemented. And the fifth pattern we are going to see is the adapter pattern. Adapter pattern is the structural design patterns. Already we have seen the facade design pattern. Now we are going to see about the adapter pattern. What adapter pattern gives is, as the word suggests, adapter, adapting. So it works as a bridge between two incompatible interfaces. So what this pattern really do is, it combines the capability of two independent interfaces. That means two incompatible interfaces are bridged together. So adapter pattern provides the way to use classes that incompatible due to difference in their interfaces. Adapter pattern consists of three main components. They are, first one, target interface. Target interface is the interface where client expects to work with. Second one, adaptee. Adaptee is the class that need to be adapted to work with the target interface. Third one, adapter. Adapter is the class which is going to adapt the adaptee to work with the target interface. That means you will understand adapter pattern. Adapter pattern consists of three main components. First one, target interface. Target interface in the sense it should be worked with the client code. And the second one, adaptee. Adaptee is the real one which we need to work with the target interface, but it's incompatible. So what we are doing is we are introducing adapter as the intermediate layer. So adapter is going to adapt adaptee, and thereafter it is really going to work with the target interface. Actually, adaptee should be worked with the target interface, but it cannot work. So, these target interface and adaptee are two incompatible interfaces. So this adapter class going to work as the bridge between the target interface and adaptee. So adapter class going to adapt the adaptee and work on the target interface. I hope this clears for you. Adapter interfaces works as a bridge between two incompatible interfaces. These two incompatible interfaces are target interface and adaptee. Target interface is the one which is expects to work with the client. Adaptee is the one which is really needed to work with the target interface, but it cannot due to the incompatibility. So, adapter work as the bridge. So, it adapts the adaptee and works with the target interface. So, adapter pattern can be implemented in two ways. First one, class. In the sense of class method, what is doing is using the inheritance for adapting one interface to another. In this approach, adapter class, that means the bridge layer, extends the adaptee class. That means here adapter class will function as the subclass for the adaptee class and also implements the target interface. So that bridge layer going to act as the subsystem. That means child class for the adaptee and going to work in the target interface. And the second method is the object adapter. Object adapter in the sense it's use composition to adapt one interface to another. So the adapter class contains an interface of the adaptee class. So adapter class, that bridge layer, going to contain the instance of the adaptee class. Okay. So adapter pattern is commonly used where the existing code needs to be integrated with a new code. That means that adaptee is the existing code. So it should be integrated with new code. Or when a third-party library needs to be used in an application that has its own interfaces. So now let's see the real example. Suppose we have a media player interface with the play method. This is one interface with the play method. And this is another interface, advanced media player with two methods, play VLC and play MP4. So these are the two incompatible interfaces, media player and advanced media player. Here media player is the code that needs to work with the client because it only has the play function. So media player is the target interface in this case. Advanced media player is the adaptee because it should work on the target interface, but it is incompatible now. This advanced media player has two concrete implementation for the VLC player and MP4 player. So these two implements these are functions. These are the concrete implementation of this advanced media player. This advanced media player is the adaptee that needs to be worked with the target interface, but it cannot work now due to the incompatibility. So now what we need to do is we are creating new class called media adapter. This media adapter is the adapter class. That means the bridge layer, which is going to connect target interface and the adaptee. Target interface is the media player and the adaptee is the advanced player. Here we are using the second method, that is object method. So in the object method, we are doing is we are passing the instance of the adapter class. You will see that in the object adapter. Here we will use in this approach the adapter class contains an instance of the adaptee class. So here that media adapter is the adapter class. It will contains the instance of the adaptee class. So now what we'll do is this is the client code. So in the audio player, we will use what we want. So this is what we have done here. Media player is the target interface. It defines the concept for playing audio files. Advanced media player is the interface adaptee. It provides additional functionality for playing VLC and MP4. VLC and MP4 player classes implement the advanced media player interface. These are the concrete implementation of the adaptee class. Media adapter class is the adapter class. Media player interface and wraps around the adaptee, which is either VLC player or MP4 player, because there are two concrete implementation for the adaptee class advanced media player. So it will wraps around either VLC or MP4 player and converts the media adapter to work with the media player interface. Finally, audio player class is the client class. It plays audio files of different formats. Now we are going to see about the sixth design pattern called as the decorator pattern. Under the structural design pattern, first we see the facade design pattern. Thereafter we see the adapter pattern. And there, as the third one of the structural design pattern, we are going to see the decorator pattern. So in the decorator pattern, it allows behavior to be added to an individual object, either statistically. Now we are going to see about the decorator pattern. Decorator pattern in the sense it allows behavior to be added to an individual object without affecting the behavior of other objects from the same class. That means we can able to change behavior of one object. That means one individual object. Other object behaviors will be remain the same. It is used to attach new behaviors to objects by placing these objects inside special wrapper objects that contain the behavior. Let's see the real world example. Let's say you have the pizza. But for the pizza, sometimes you need to add some toppings. For example, like cheese. If you add cheese, the price will change. Otherwise, the price of the pizza remains constant. So here, cheese topped pizza only needs to be changed. So that objects only need to be changed. Only some behavior needs to be added for the cheese topped pizza, while others remain constant. So what we are doing here is, we are creating public interface pizza. And in the pizza, it has two methods, get description and get cost. It has a concrete implementation for the class called plain pizza, which implements that interface pizza. So it will be like the normal pizza class. And now I'm going to create the decorator abstract class. So here public abstractor class topping decorator, which also implements pizza. Here we are passing pizza. And also we are passing as the instance also. We are implementing it and also we are passing it as the instance. Here also we have two methods, get cost and get description. And thereafter, for this topping decorator, we have the concrete implementation because this is the abstract class. So we have the concrete implementation for the public class cheese extends topping decorator. Here what we are doing is, for the get description function, we are calling the pizza get description with adding with cheeseburger extra. And here also in the get cost also, we are calling the pizza get cost function. That means this function. And we are adding extra 1 rupees. So in the pizza client class, in the pizza shop, when we are calling the pizza and adding a new topping called cheese, because we are creating the class. So when we are creating the class for the new toppings, here what we'll do is, it will add the new behavior while other functions remain the same. Here I have explained these in the terms. So this example demonstrates the decorator pattern by allowing new behavior, adding cheese to a pizza to be added to a pizza object without affecting the behavior of other pizza objects. Now we have three examples for the structural design patterns. Now let's move into the behavioral design patterns. As the seventh design pattern, we are going to see about the strategy pattern, which is the behavioral design pattern. As we already see, behavioral design patterns says how you need to communicate between objects. So as the same, Here, strategy pattern implies that it enables selecting an algorithm at the one time. So, for example, you have the interface called sorting strategy. Here we provide the general interface. Here we have two concrete implementations for the bubble sort and quick sort. Under these class, we have the general implementation. And here we have the um, uh, class where we need to switch. And here this is the client class. Here we will switch between the algorithm at the one time. Here we have seen the strategy design pattern. As the last topic of the context, we are going to see about the observer design pattern, which is also the behavioral design patterns. As the name suggests, observer pattern, it defines a one-to-many dependency between objects, so that when one object, that means subject, that one object is called as the subject, changes its state, all its dependent objects, that means dependent object on that subject, these are called as the observers, are notified and updated automatically. In this pattern, there are two main entities, subject and the observer. Subject is the object that is being observed. That means this is where the change is going to be happened when one object changes its state. So object is being observed by others is the subject. And the observer is the object that observes the subject. That means dependence on the subject. When the subject changes, it notifies all the registered observers because one-to-many dependency. So it notifies all the registered observers which can take some actions based on the new state of the object. Let's see the example. Here we have defined the interface for the subject. Here we have defined the function for adding new observer, for removing the observer already present, and for notify the observers. Here using the subject class, we are going to make the concrete implementation. So using that subject, we are going to implement weather station. So in the weather station, you can add new observer, you can remove the observer, and also able to notify the observer. In order to notify the observer, you are calling the observer class. This is the observer. So observer class, you are passing that observers here. So observer class and the update function of that observer class. This is the update function of that observer class. So when the measurement change of the weather station, it will notify observer functions is called. So in the notify observers function, we are calling observer.update. That means for the observer class, we have the update function. So that function will be called. This is what we see for the subject class. And now we are going to see for the observer class. For the observer class, we are creating the general interface with the update function. Thereafter, we are going to implement the concrete for the observer implementation. Public class current condition display implements observer. It will implement this observer interface. So here, it will take data from the subject weather data and display those data. And sorry, when the class is created, it will call the constructor. This is constructor, public current condition display, same name, no return type. So this is constructor. So constructor is hold. And in this constructor, we are passing subject with the data. That means we are passing this subject object, and in the subject object, we are calling the function register observer. That means it will call this function. So in the already present list, it will add new instance of this. So registration of this instance is called the uh, this function. And when the update function is called here, this function will be executed. So this is how observer design pattern works. When the subject change, it will notify all the registered observers. So observers are observing the subject. Now we have seen some of the examples for the design patterns. As we have already seen, design patterns are the common solutions for the recurring, common problems. So, in the design patterns, there are main three types: creational design pattern, structural design pattern, and behavioral design pattern. Creational design patterns, in the sense, it will say how you need to create the object. Structural design patterns say how the composition of the class and objects are. Behavioral design patterns say how the objects are communicating between each other. Under the creational design pattern, we have seen about Singleton design pattern, factory design pattern, and the builder design pattern. Singleton design patterns means we are having only one instance for that class and only one global access point. Factory design patterns means we are providing common interface for creating objects, but we are really creating the object during the runtime. And the third one is the builder design pattern. Here we are separating the separating the building function, creating function separately. We have seen email builder class. So for the email builder, we have created as the inner separate class. So we are creating the separation function separately. These are the three design patterns we have seen under the creational design pattern. Then we are seeing about the structural design pattern. Under the structural design pattern, we are seeing about the facade design pattern, adapter design pattern, and decorator design pattern. Facade design patterns means we are hiding the implementation, hiding the complexity and providing just a simple interface. Only clients get to know about the simple interface. It does not know how the real complexity are. That is the facade design pattern. And adapter design patterns mean when there are two incompatible interfaces, there will be which layer will be introduced. That is the adapter class. And it will make sure the adaptive class to work with the target interface. And the third design pattern we have seen is the decorated design patterns. It allows to change the behavior of the individual object. That means we are adding new behavior for the individual object by wrapping it to the special category. We have wrapped cheese pizza to the special category rather than the pizza. So in addition to the pizza functions, we have changed some of these functions. And thereafter, we have seen the behavioral design pattern. Under the behavioral design pattern, we have seen strategy design pattern and observer pattern. In the sense of strategy design pattern, we have seen uh, we are implement the different sorts of algorithm, and we make sure to which algorithm we are switched on the one time. We need to use bubble sort or quick sort or which sort during the one time. And observe a design patterns in the sense there is a one to many dependency. One object that is subject that might be changed. So all the dependent objects, that mean observers, notified and updated automatically when the subject changes. So these are the 8 design patterns we have seen. I hope you will enjoy this video, and if you have any clarification, you can contact me over my LinkedIn. My LinkedIn is Stephen Govindaya. And by the way, you can follow this WordPress also. My WordPress is deepsbook.com. Okay, guys, I will meet you in my next video. Bye bye. If you didn't subscribe my YouTube channel, please subscribe this as well.